Lecture 3 Deformation of a body subjected to axial force. Consider a body which is subjected to axial force or load. This is axial force. Consider this P axial force, pulling force, gauge length. This is gauge length. This to this change in length. P axial load. A original area. L original length of the body. This is cross sectional area. Change in L, change in length of the body. Stress is equal to P over area. Strain is change in L over L. We know that modulus of elasticity is equal to stress over strain. Strain is equal to stress over modulus of elasticity. Change in L over L is equal to P over area over E, PL over A. This is change in L, or deformation is equal to PL over A. This is load times original length over area, sectional area, or modulus of elasticity. Example 1. Prismatic bar with rectangular cross section 25-45 mm and length 3 meter is subjected to an axial tensile force of 70 kN. The measured elongation of the bar is 1.2 mm. Calculate the tensile stress and strain in the bar. Solution: given axial pull 70 kN, cross sectional area 25-45 mm. This is 1125 mm square. Length of the bar is 3 meter, 3000 mm. Elongation of the bar is change in L 1.2 mm. This is axial pull 70 kN. Stress is equal to P over area 70 times 1000. This is over 1125. This is 62.22 Newton per millimeter square. Strain is equal to change in L over L 1.2 over 3000 is equal to 0.004. Extension of lecture 3. Example 2. A brass bar having cross-sectional area of 900 mm square. Cross-sectional area of 900 mm square. Brass bar is subjected to axial forces as shown in figure below. Find the total change in length of the bar. Take modulus of elasticity 1 times 10 to the power of 5 Newton per millimeter square. Is 40, is 70, 20, 10, A, B, C, D, part 3, part 1, part 2, part 3, 3 parts. 600 lengths, 800 millimeter, 1000 millimeter. These are lengths. Solution: for part AB, this 70 is applied on part 2, not on part 1. 20 is applied or subjected on part 2, not on part 1. This is applied on this. Okay, for part AB, L1 600 millimeter, area cross section is 900 millimeter square. Modulus of elasticity is 1 times 10 to the power of 5 Newton per millimeter square. 40 kilonewton is applied here. In opposite direction, 40 kilonewton. From 40 kilonewton is equal to P1 prime. P1 prime. This is for equilibrium. To keep in equilibrium, minus 40 the negative direction of x plus P in the positive direction is equal to 0 for keep to be in equilibrium. P1 is equal to 40. For part BC, this is 70 kilonewton is applied at this point, and the other, which is come from this, is applied on here. This is tensional force. This is tensional force over here. This is also tensional force. Because this is tensional force here. Tensional force on part 1 And also this is part on part 2, it is tensional force. This is 70 in the x direction, 70 minus p at this point equals to blank space. 70 minus 40, 30. 30 is absent is 30. 30 is applied on the right direction, that is comparational force. From this, at this point, for part 2, at this point, 20. This is 10 kilonewton. From this this is 10 kilonewton. On this applied for P2 is applied cross section. This is compressional force. This is compressional force. Also this is compressional force. P2 prime is compressional force. P2 prime plus 20. This is 10. This is 10. P2 prime plus 20 is equal to 30. Ziga at this point this is 20. Applied force is this is P2 prime. This is also compressional. This is also compressional force. P2 prime, T2 prime. This is P2 compressional force. So this is compressional force. On this it is compressional force. This also it is compressional force. P2 plus 20 is equal to 30. P2 plus 20 is equal to 30. This is P2 is equal to 30 minus 20. This is 10 kilonewton. Then for part CD, this is 10 to keep in equilibrium. 10 minus 20 minus P2 minus P2 is this. P2 minus 10 in the negative direction is equal to 0. P2 is equal to 10 kilonewton. Change in length, then change in length. Change in L1 or part 1, P1, L1, A1, E is equal to 40 kilonewton, 4000 kilonewton times 600 length over 900 cross sectional area times modulus of elasticity 10 to the power 5 is equal to 0.267 millimeter. Positive. This is tensional. Change in L2, PA2, L2, A, E. This is 30,000. This is 30,000. This is 40,000. This is 30,000. This is 30 compressional force. This is 30 on this object. From this 30 compressional force. 30,000. 30,000 is 40,000. This is 0.267 negative. This is compressional. Change in L3, P3, L3 over A3, A. This is 10,000. Since this is 10 kilonewton, this is 10,000 times 1,000. This is length is 1,000 and over 900 cross sectional area times 10 to the power 5. This is 0.11 compressional. That's negative. Total change in length is equals to change in L1 minus change in L2 minus change in L3. 0.267 minus 0.267 minus 0.11 is equal to negative 0.11 millimeter.